So this is our setup for measuring the solar cell characteristics. We have a main kit over here which contains two digital meters. One is a voltmeter, another is an ammeter. The circuit connection diagram is shown on the board itself, and we also have a resistance bank having different values of load resistances. We have a detailed manual which is given with the kit. We have the jacks which are required for performing the experiment. Now we have a black box which mainly houses the light source, which is a 100-watt tungsten bulb, and we also have the solar panel, as you can see over here. This can be moved with the help of the screw given behind. So you have to set the position such that we are getting the maximum voltage in the voltmeter. So for the time being, we'll set it around here. Let us now see the circuit connection. So we are connecting the positive and negative of the solar panel to the positive and negative of the circuit. Next we connect the voltmeter. Then the ammeter is connected, and finally we connect the load resistances. Let's just go through the manual very quickly. We have the aim, the apparatus required, and the theory for the solar cell. The circuit connection, the circuit diagram is given along with the graphs, the IV characteristic curve. This is the ideal power, the maximum power, the fill factor, the efficiency, and we have the circuit connection given in details in the manual. The procedure is given in details, and along with that we have a observation table. Please note that this is for reference purpose only. The readings will vary from kit to kit. And finally we have the IV characteristic curve as well as the power curve. And finally we have the result and the calculations for the efficiency of the solar cell. As you can see here, the voltage is coming as 3.1 volt. Here this is in no load condition. We have disconnected the load and the current is 0. So this is our maximum voltage. We will again short circuit the load and we'll find out the short circuit current. So this is our short circuit current, 8.5 milliampere. Now we are connecting the load resistance. So 10 ohm is connected. As you can see, the voltage has dropped considerably and the current is around 8.4 milliampere. Likewise, we will keep on changing the load resistance and we will note down the corresponding current and the voltage. These resistances are connected in series, so as you go on increasing the resistance, the load resistance, the current will decrease and the voltage will increase. So we will note down this reading in the observation table as given here. We have already noted the open circuit voltage, the short circuit current, and the wattage of the bulb is given as 100 watt. From there we will draw the IV characteristic curve, and from here we will find out the VM and the IM values. We will also draw the power curve and the maximum power, the PM we will also find out, and from there we will do the calculations of ideal power, maximum useful power, fill factor as well as efficiency. So that concludes our experiment for the solar cell characteristics setup. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.